In today's video, we're going to see memory mapped I/O versus I/O mapped I/O. So in a microprocessor system, there are two approaches to mapping our input-output devices. One is memory mapped input-output and other is I/O mapped input-output. So in a memory mapped input-output devices are basically mapped to the memory address of the microprocessor. What that means is we typically have a microprocessor, a memory with all of the buses available in the memory, and the input-output devices that we have are mapped to the address space of our memory, and they are not directly connected to the microprocessor. This also means that the I/O devices are treated like memory locations and can be accessed using the same read and write instructions as memory. So let me write this down. I/O devices treated like memory locations. Also, to add on this, if I/O devices are treated as memory locations, then we basically use STA, LDA, STAX, LDAX instruction for getting the data from input output devices to the microprocessor or sending the data from microprocessor to the input output devices. Also, the same bus and control signals that are used for memory access are used for input output access too. So same bus used for memory and I/O access. Well, on the other hand, in an I/O mapped I/O, input output devices are mapped to a separate I/O address space or input output address space that is different from the memory address space, which means we have a microprocessor will have a separate memory, but the input output devices are actually mapped using ports here, and they are not connected via the memory system. So the microprocessor actually uses special instructions to access the input output devices. Now we'll see much more differences of memory mapped I/O and I/O mapped I/O in this. The first one we've already addressed is the method of addressing. In addressing, in case of memory mapped I/O, input output devices are accessed like any other memory locations, while in case of I/O mapped I/O, they cannot be accessed like a memory locations. They need to be connected through several separate approach to the microprocessor. The second one is based on address size. The address space used in memory mapped I/O is actually of 16-bit address, while in case of I/O mapped I/O we use 8-bit addresses here. Again, like I already told you that LDA, STA, STAX, LDAX instructions are used to access the input output devices in case of memory mapped I/O, while in case of I/O mapped I/O we use in and out instructions in 8085. Next point, we can say that 2 to the power 16 I/O ports are possible in case of memory mapped I/O, since the address is of 16-bit, right? But in case of I/O mapped I/O, only 2 to the power 8 I/O ports are possible. And in terms of instruction set, in case of I/O mapped I/O, we use the same instruction set as we use for memory location access, while in case of I/O mapped I/O, we use a separate instruction set in this particular scenario. Now in context of design complexity, we can say that memory mapped I/O is much more simpler to implement and design, while in case of I/O mapped I/O, it is more complex than memory mapped I/O to implement and design. So These are the differences between memory mapped IO and IO mapped IO. To summarize this, eh, these are these are two different approaches to interface any input output device to the microprocessor.